Hello and welcome to Physics Made Simple by Dr. Eid. Today's topic is going to be describing the motion of an object. So going over constant speed, I want you to remember that the word constant speed is basically uh, cruising when we are in a car. So our speed is remaining the same throughout the time that we are traveling if we were to put it on cruise control. So looking over here, you guys can see that as time passes, 1 second, 2 seconds, 3 seconds, we are actually remaining at 10 meters. Therefore, constant positive velocity is basically zero acceleration. We are not speeding up, we are not slowing down. All we're doing is traveling at the same speed or at the same rate of speed. So as the time passes, the velocity remains at 10 meters per second, as you guys see. If we were to be looking at the position, notice the position is actually changing, but the speed is remaining the same. So 0 meters at 10 meters, we we traveled the 10 meters, okay, but that was in 1 second. So at the next second, we traveled another 10 meters. So it's 10 meters per second. Constant, again, constant speed is basically moving with zero acceleration. So unlike constant velocity, positive velocity is actually a change of velocity over time. And as we can see here, the change is in the positive quadrant, and that's why it's called positive velocity. So these objects are moving with positive velocity, but it could be either going closer to zero or what we call slowing down. And this is what it looks like, or it could be moving away from zero or speeding up, as we can see. Now, how do we find a point, or how do we find the velocity at a certain point? So for example, at point X, what is Y? Or at a certain time, like 3 seconds, if we want to use that as an example, we extend that to the slope and go back to point Y and figure out what V is or what point Y is. So negative velocity, just like positive velocity, we know that these objects are moving with negative velocity in the negative quadrant of the graph. So noticing here, if an object is actually slowing down, we know that that object is heading towards zero and it is in the negative quadrant. And if the object is speeding up, we know that it is going away from zero and still in the negative quadrant. It's just like backing up in a car. You are moving away from your initial position and you are speeding up away from your initial position, and time is still passing. How do we figure that out? Exactly the same way that we figured out the positive velocity. We look at our x, which is point time, where is y, which is the velocity. So at time 3 seconds, what is the velocity? We extend that line and figure out to the slope and figure out what y is. So the next thing we're going to go over is acceleration. And acceleration is basically the rate of change of the actual velocity with time. So velocity is changing, but now it's actually changing quicker. So at the beginning, it might be changing 10 meters per second. The next thing you see, oh my gosh, we have to speed up even more because we have to catch up to traffic, for example, on the highway. That being said, I have to speed up even more. I have to basically step on the gas and move forward. Or it could be the other way around. A lot of times we need to do negative acceleration, which is slowing down quickly, because if somebody jumps up in front of us, what do we need to do? We need to step on the brake and quickly change that speed so that we will come very close to a stop, or maybe we need to come to a complete stop. That being said, let's go ahead and go over acceleration. So with positive acceleration, we know that we need to be calculating the rate of change of the velocity over time, which in here we see a steady change, which we see the slope increasing in the positive direction and it's going up. So the velocity is increasing. And to find the acceleration using this graph, we need to basically find the slope. And again, the slope is basically figuring out the rise over the run, and whatever velocity it is, the rise divided by the run, because it's steady. So no matter what point you choose, that acceleration should be the same. So if it's going to be at 6 seconds, okay, you go up and it is 3 meters per second. So the acceleration is going to be 3/6, or 1/2 meter second square. Remember, the um, units for acceleration is actually meter second square, because we have double the seconds. We have the seconds from the velocity as well from as well as the time. So again, the change or the rate of change in here is a steady change. So if I choose a 3/6, it's going to give me zero point 0.5. And if I choose a 2/4, or it's going to be zero point 0.5. If I choose any other number, up or down, should give me the same acceleration, because notice that line is a straight line and the rate of change is the same. So again, there is a change, and it's a positive change, and that change is a steady change. So no matter what point we choose, it should be exactly the same. And since it's again going in the positive direction, it is going up, and that is called a positive acceleration. So with negative acceleration, it's basically very similar to the positive acceleration, but you see a rate of change of the velocity in the negative direction. Number one, you see that rate changing. Basically, you see that number or that velocity changing at the same rate, which means any point on the rise over the run you choose along that slope should give you that same exact number. How do we find out the acceleration for a graph that looks like this? It is basically the rise over the run. No matter what point you choose, it should give you the same. How do you plug it in? If you know that the rate of change is the same, and you have that number, you can go ahead and plug it in, so that you will see a negative acceleration, direction going down, and the slope is decreasing. Um, Again, uh, any point that you choose along the rise over the run should give you an acceleration that is going in the down in the negative direction. So displacement is basically finding the area covered by an object within a certain time. And to do that, to find displacement, you have using a graph, you have to use the formula for an area that we use in math, which is 1/2 base times height. And that formula is only used if we have an acceleration that is steady, and if we have a triangle. So the area of a triangle will be 1/2 base times height. And like we said, if we are to find the acceleration that is a steady acceleration with a steady slope or a straight line, it should be the same exact number along that line. Now, the area covered by the object should be the formula we use for the triangle, which is 1/2 base times height. The direction of motion is something that we are going to need when we draw motion maps, and it is very important to learn how to read it from a graph. If the velocity is positive, then we know that the object is going to the right. If the velocity is negative, then we know that the object is going to the left. So if I have a motion map with arrows, and we will go over that in the next video, if the object is going to the right, we know that it's a positive velocity. If the object is going to the left, then we know that it's a negative velocity. So constant positive velocity is a constant change within a period of time uh, to the right. constant. Negative velocity is a constant change with a certain period of time, within a certain period of time to the left. So just a quick summary. In order for us to describe the motion of an object, we need to learn the direction this object is moving in. If it's uh, a uniform velocity, you are going to be seeing a straight line. A positive velocity, it is going to be above or in the top quadrant. If it's a negative velocity, it is going to be in the lower quadrant. If we are seeing a change in velocity, we are not going to be seeing a straight line along that same point. We are going to see an increasing straight line, or a moving in the positive direction, speeding up straight line. If we have an acceleration that is going down or slowing down, we are going to see it going in the slowing down direction or going towards zero. So a slowing down is going to be going towards zero, whether it is from a negative velocity towards zero or a positive velocity towards zero. A speeding up a direction or a speeding up object is a straight line going uh, from zero and away in the positive direction, or from zero and away in the negative direction. How is that possible? Sometimes in a car, we can back up. And as we back up, we change at a certain rate or speed up backwards. And that is very possible. If you have any questions regarding acceleration or velocity, go over these slides and uh, try to understand the step by step and the difference between understanding the velocity and the acceleration. Velocity is basically a speed with direction. Acceleration is a rate of change of that velocity within a certain period of time. Thank you for watching this video. Coming up is going to be basically motion maps and how to read uh, motion and direction of an object. Thank you.